Oh boy, here I am, ready to do problem example number 2. So we have this, we're going to say there's no friction here, so this is going to be kind of crazy. We have this little mass M down here, and it's hooked up to this pulley system, and it's going to grab big M here. And so as little m falls, it drags big M with it this way. Oh my gosh, and then it goes down. That's crazy. Now, let's draw a free body diagram for big M. Well, I have the normal on big M. Notice because I have big M and little m, I'm going to label those with little subscripts. And then I have the weight of big M here. Notice I called it FGN number 1W here. I can use whatever I want, and you need to get used to that because that's going to happen a lot on the AP. And then I have the tension. The rule for tension, again, is you draw an arrow going out of the rope this way, dragging mass M. Now, the rule for tension, as I said, is it always points out of the object, pointing away from it. So for little m, I'm going to have the weight of little m pointing down. Now here's the interesting thing. I know little m falls and gains speed. So what that forces me to conclude is, I drew the tension like this here, and these two should actually have the same length. And one other thing is, because I know that the little mass falls down, I'm going to actually draw its tension as being bigger, or its weight as being bigger than the tension. And I'm going to assume that big M's heavier, so I'm going to make its weight actually quite a bit longer. And I'll give its normal force, I'll actually give it quite a bit more length, just so that it balances. There we go. So this is really what the free body diagram should look for this situation. There's no more forces to draw. And what we're going to do later on in this lecture is learn how to actually turn these free body diagrams into equations. But for now, this is the free body diagram.